Hi, I'm Enrico Gallinucci and I'm here to showcase NoSQL-Budgeteer. This is a tool that we developed to estimate the monetary cost of document-based databases in the cloud, where costs are estimated with a cost model that considers two main factors: the storage occupation, which is a direct result of the logical model of the collections and the denormalization choices that we do, and querying, where costs are usually driven by the amount of data that is read or written in both terms of indexes and actual data. So our goal with this tool is, on the one hand, to estimate the costs for a given workload on a given logical model, and also to compare alternative solutions to find the most convenient one. This is the tool that is freely available on the website of our research group as a web application. It is pre-configured with the online store domain, which is the typical use case with customers making orders about products and other information about category suppliers and so on. Now here we don't need the actual data, we just need metadata about the entities and relationships in the domain and the cardinalities of the entities, of the relationships, and the attributes and the respective data types. In the settings view, you can configure the parameters of the cost model, which include the amount of bytes that are required for each document and for each data type, and pricing for storing the data and for reading and writing data and index entries. These, of course, can be configured based on the cloud provider that one wants to try, and these default values are based on current prices that we have for Azure Cosmos DB. So after configuring the domain and the cost model, we can load new solutions, which are JSON files that include the specifics of the logical models for each collection that we want to implement for the domain, including all the denormalization choices that we apply within each collection. We can see them both in this schema view, which includes the indexes that we have for each collection, or in this graph view where we can notice that, for instance, here we have a lot of redundancy for the order and item and product entities, which are repeated in multiple collections. If we go in this details view, we can see some statistics computed by the cost model in both terms of the storage occupation of each collection, both for the documents and for the indexes, which are then aggregated and converted into monetary costs, and the same for the query plans, each of which may include multiple accesses to different collections where the join is assumed to be done on the application side. So for each access to a different collection, we can see statistics about the estimated number of documents and the index entries that we will read with the respective amount of bytes, which will then be multiplied by the frequency of the query and converted into dollars, which are finally aggregated down here. These statistics are then aggregated in this analysis view where we can see summaries for both the storage and query volume and costs. For queries, we can see them both in terms of number of documents and index entries that are read or written, volume of megabyte, and actual monetary cost. So from here, we can get an estimate of how much a solution would cost us in a given cloud provider. And then the interesting thing is to compare it with a different solution. So for instance, here we can load a different implementation of the same domain with collections, where in this case we have no redundancy for the entities in the domain. And here we can go to this comparison view where, for instance, we will see here that the storage occupation is the one that weighs the most because the workload queries are actually executed quite unfrequently. So the solution with a lot of redundancy ultimately is the one that weighs the most. So then what we can do is to try out a different scenario where the workload queries are more important. So let me load new files where we have scaled the frequency of read queries to a higher order of magnitude. So you can see them here that the frequency for read query is much higher, of course, in both cases. And then if we go back to the comparison view, we will see that now the solution where we have redundancy in place becomes more convenient because ultimately the cost of the querying is less than the one with no redundancy, but where query plans are more complex to be executed. So this is a very quick overview of our application. Feel free to try it out on our website and let us know if you have any comments.